Hi everyone, today we're going to be exploring the integral from 0 to pi over 2 of x over sine x plus cosine of x dx. So, actually we're going to be tackling this integral using what is so-called the King's rule, okay? So the King's rule is pretty much famous when solving integrals that involve the trigonometric functions such as sine and cosine. So what does the King's rule say? The King's rule say that if we have the integral from a to b of f of x dx, this is equal to exactly the integral from a to b of f of a minus a plus b minus x dx. And actually, you can prove that rule, the King's rule, pretty much easy. You can take a substitution for u equal e plus b minus x. Hence, the u is going to be minus dx. And you're going to change the integration. So now we have the integration from. So let's get u of a. So u of a is gonna be equal to when you substitute a here. So this is a minus a is b. So u of a is b, and u of b is gonna be a. So that's the integral from b to a of f of u, and we have the dx is minus du. So let's move the negative sign outwards. So it's equal to the integral from b to negative the integral from a to b to a of f of u du, which is exactly equal to the integral from a to b of f of u du. And of course we know that this is the u is a dummy variable, so it doesn't matter if it's an x, u, whatever. So we're gonna see how this rule actually helps us to solve the integrals. So let's call our integral I. So we're calling our integral I. So I is equal to the integration from x of 0 pi over 2 of sine of x plus cosine of x dx. So now let's apply the King's rule. So now we know that I is equal to the integration of 0 to pi over 2 of pi over 2 minus x over sine of pi over 2 minus x plus cosine of pi over 2 minus x. So now we have some trig identities here to apply and trig formulas. We have the difference of sines and cosines. So let's see what is pi sine of pi over 2 minus x is equal to. This pretty much is equal to sine of pi over 2 cosine of x minus sine of x cosine of pi over 2. So we know for sure that cosine of pi over 2 is actually equal to 0, and sine of pi over 2 is equal to 1. So this is equal to cosine of x. And let's see the other one. We need to get the value of cosine of pi over 2 minus x, which is exactly cosine of pi over 2 cosine x minus sine of pi over 2 sine x. So yeah, this is minus, so this should be a plus. Okay, so we know that cosine of pi over 2 is 0 and sine of pi over 2 is 1, so this is equal to sine of x. So pretty much that this is equal to cosine of x and this is equal to sine of x. So let's see what we can do. So now again we have the I is equal to 0, and the integration from 0 to pi over 2 of pi over 2 minus x over. Now this is cosine and this is sine, and this is a plus, so we know that addition is associative, so we can actually exchange them. So sine of x plus cosine of x, and this is dx is the same. So this integral can easily be separated into two different integrals. So it's the integration from 0 to pi over 2 of pi over 2 over sine of x plus cosine of x dx minus the integration of from 0 to pi over 2 of x over sine of x plus cosine of x dx. And if you're noticing here that this is essentially the same as the integral I that we have defined in the beginning of the video, right? This is I, and we've said that I is equal to, again, the integration from 0 to pi over 2 of x over sine of x over plus cosine of x dx. So now we have the I is equal to, so let's focus on this part here. So now we have the I is equal to the integration of from 0 to pi over 2 of pi over 2 over sine of x plus cosine of x dx minus, and this is I, right? So now using some algebraic manipulation, and it's not really manipulation, we're just moving things around. So we can move this negative I to the other side to be plus I. So now I plus I is just 2I is equal to the integration of from 0 to pi over 2 of pi over 2 over sine of x plus cosine of x dx. And now let's move this to the other side. So now we have the integration of, let's move this one here because it's a constant, and this one here. So pi over 2 is going to be pi over 4, right? So it's pi over 4, the integration from 0 to pi over 2 of 1 over sine of x plus cosine of x dx. Now this is pretty much easier than this one, right? So we have transformed our integer from this one to this one. So now what we can do is we should integrate 1 over sine of x plus cosine of x and then multiply it by pi over 4 to get the original value of our integral, which is the original one, which is x over sine of x plus cosine of x. So there are many ways to integrate sine of x plus cosine of x, but what I'm gonna use here is using some help of the complex analysis. So I know that sine of x plus cosine of x, I need to simplify that, okay? So I know that this is, as a whole, this is a sinusoid, right? This is a sinusoidal function. So I can pretty much write sine of x plus cosine of x as only one sinusoidal function with somehow a phase shift, right? And a change in amplitude, right? So I know that sine of x is equal actually to cosine of x minus pi over 2, right? We know that because when you draw the sine, this is sine of x, and this is cosine of x, right? This is cosine of x pretty much, right? So we know that somehow the cosine of x is somehow leading the sine of x, right? So the peak of the sine of x, if this is y and this is x, so the peak of the cosine of x exceeds or is leading the peak of sine of x. So this means that if we subtract pi over 2 from the argument of cosine of x, we're gonna reach the sine of x, right? So now we can substitute for sine of x as cosine of x minus pi over 2 minus plus cosine of x. So now I need to simplify what cosine, let's move that here. I need to simplify cosine of x minus pi over 2 plus cosine of x. So what I'm going to use here is what is so-called the phasor representation of complex numbers, okay? So I'm going to use a phasor representation. So I'm going to represent the cosine as just the value of its amplitude and the phase shift. So the first one, we have an amplitude of 1, right? And we have a phase shift of negative pi over 2, right? And the second one, we have what? We have an amplitude of 1 and an angle of 0, right? We don't have any phase shift in the second one, right? So if we draw that on the complex plane, if this is the imaginary plane, and let's focus on this one. So this one has a magnitude of 1. So magnitude of 1 and angle of 0, this is exactly where the magnitude of 1 is 1 and the angle is 0, okay? So the angle is actually what the vector makes with the x-axis, okay? With this axis. So 1 and 0 is just this one. And 1 and negative pi over 2 is just also this one, because we know that this is negative pi over 2, right? So this is exactly 1 and negative pi over 2. We know that this length here is 1, this length here is 1. So we somehow need to find the resultant or the summation of that, okay? So the summation is somehow going to be like that. We have that here and that here. So this is somehow is going to be the summation, right? Okay. So the resultant is going to have their magnitude, okay? The magnitude of the resultant is going to be 1 squared plus 1 squared under the square root, and the phase shift is going to be, so let's focus on that here. We have this vector here and this vector here, and this is the resultant, right? We know this is 1, and this is 1, and this is root 2, right? Which is 1 squared plus 1 squared. So the angle that it makes is actually, we can find that pretty easy, right? It's equal to tan inverse of 1 over 1, which is pi over 4. But we know that it's negative pi over 4 because it's in this quadrant, right? So this is negative pi over 4. So now the angle is negative pi over 4. So now the phase representation of that is just root 2 negative pi over 4, right? So now converting that to the original cosine function that we have, it's going to be root 2 is the amplitude of the cosine, root 2 cosine of x minus pi over 4. So we can pretty much say that sine of x plus cosine of x is equal to cosine of x minus pi over 2 plus cosine of x, which is equal to finally root 2 cosine of x minus pi over 4. So this is what we need to integrate the reciprocal of it, okay? So now let's get back to our integration. We know that this is our integration. We know that this is integration of from 0 to pi over 2 of 1 over sine of x plus cosine of x dx, and now we know that sine of x plus cosine of x is equal to root 2 cosine of x minus pi over 4. So now let's get a new page. Oh, I'm sorry. So now let's get a new page here. So I'm sorry for the sudden shift in the colors, okay? So let's see. Yeah, now we know that it's equal to pi over 4, the integration from 0 to pi over 2 of 1 over, now this is what we said, it's root 2 cosine of x minus pi over 4, right? dx. So now we can move this root 2 to outside the integer, so the I is equal to pi over 4 root 2, the integration from 0 to pi over 2 of 1 over cosine of x minus pi over 4 dx. Okay, this is so great. So let's rationalize the denominator here. We have pi over 4 root 2. We can multiply by root 2 and root 2. So it's pretty much equal to pi root 2 over 4 times root 2, which is root 2 times root 2, which is 2. 4 times 2 is 8. So integration is equal to pi root 2 over 8, the integration of 0 to pi over 2 of 1 over cosine of x minus pi over 4 dx. So now let's make a simple substitution here. Let's make u is equal to x minus pi over 4, and obviously du is equal to dx. But we should change the boundary of the integration. So u of 0 is equal to 0 minus pi over 4, which is negative pi over 4, and u of pi over 2 is equal to pi over 2 minus pi over 4, which is pi over 4. So now we have the integration of pi root 2 over 8, 0 and pi over 2, sorry, negative pi over 4 of 2 pi over 4 of 1 over cosine of u du. So this is really easy to integrate. So it's the integration of pi root 2 over 8, the integration from negative pi over 4 to pi over 4 of secant of u du. And of course we know that the integration of secant of u is just so we know that the integration of secant is equal to ln secant of x plus tangent of x, right? So therefore I is equal to pi root 2 over 8 ln secant of u plus tangent of u, and then our boundaries, which are from minus pi over 4 to pi over 4. Now let's substitute. So the first one, is equal to, let's keep that outside. So yeah, so secant of pi over 4 plus tangent of pi over 4, and then minus len secant of negative pi over 4 plus tangent of negative pi over 4, and then we should work out the values of these check functions. So let's see, we have we need to get secant of pi over 4, which is exactly 1 over cosine pi over 4, and we know cosine pi over 4 is root 2 over 2, so secant pi over 4 is going to be the reciprocal of that, which is 2 over root 2. Okay, and secant, obviously secant of negative pi over 4 is the same answer, because we know that secant is an even function, so it's essentially the same thing. It's 2 over root 2. Now let's work out tangent of pi over 4, which is 1 obviously, and tangent of negative pi over 4 is obviously negative 1. So let's substitute pi root 2 over 8. Now we have len, so this is 1 plus 1, okay, so we don't need the absolute value, it's just 1 plus 1, okay, minus len, so this is also 1, right? Oh, I'm sorry, we're wrong here, I'm sorry. Yeah, this is 2 over root 2, sorry, plus 1, which is obviously a positive number, so we don't need the absolute value. So this is 2 over root 2, and this is 1 minus len, again this is 2 over root 2, and this is minus 1, right? Yeah, this is minus 1. So again, this is a positive number, so we don't need the absolute value. So we can just somehow rationalize this thing and then combine the lens together. So this is gonna be 2 over root 2 over 2 root 2 over 2, right? Because if we rationalize the denominator, so this is just root 2, right? Okay, plus 1, great. And this thing is here is also root 2 minus 1, so this is a pretty much good result. Len root 2 plus 1 minus len root 2 minus 1, so therefore our integration is equal to pi root 2 over 8. Now we can just combine the len into division, so it's len root 2 plus 1 over root 2 minus 1, and this will be the final answer. Therefore, so we can pretty much say that the integration from 0 to pi over 2 of x over sine of x plus cosine of x dx is equal to pi root 2 over 8, the len natural log of root 2 plus 1 over root 2 minus 1. And this pretty much summarizes our result and summarize our video. I hope guys you have enjoyed this video, and if you need any more integrals to be solved, just type in the comments. And thank you for watching. Goodbye.